We are delighted today and pleased to having all of you. And on behalf of myself and all my colleagues here in SASU, we would like to welcome all of you, especially our guests today, Dr. Jean-Claude and Miguel Gonzalez from Doubont Company. And SASU always so keen to organize and participate in such events. Because from our point of view, we think such seminars and workshops is a great platform to exchange the knowledge and experience regarding the standardization matter, especially what we are talking today about it, the safety. Now, I will have a quick presentation about SASU. I will give you a brief introduction about SASU. Then I will talk about our national committee related to the protective and safety equipment. Then we will talk about our national work. Then I will close my presentation by talking about outlook and what we're looking for. This is my presentation. As I said, I will talk about SASU in brief, then I will talk about our national committee, and a scope of ISO TC 924, which is related to the safety and to the protective and clothing safety equipment. Then I will talk about the ISO TC standards. Then finally, we will talk about outlooks and what we are looking for. Of course, this is the SASU vision. Here in SASU, we are looking for to achieve the regional leadership as a scientific reference body in fields of standardization and conformity assessment. And to translate that to reality, we have our mission here, which elevate the standards and the quality of products and services to protect the consumer and strengthen the competitiveness of our national committee. This is always the main goals of any standardization system, which is the protective, the consumer, and how can you make your national committee more competitive. Then, here in SASU, we are aimed to three main things, which we shall be the authority of charge of all the standardization matters and conformity assessment and granting of the quality and metrology and calibration. As I said on the last slides, the main things or the main goals of any standardization system, it's how can you protect your consumer, and that's where translated in this point, ensure the health and environmental protection and public safety through what? Through the technical standards and regulations. That's approved by SASU. Then we ensure the quality of our national product. Why? To make this national product is more competent in domestic and international market. And also we have to protect our market from the counterfeit commodities that comes from outside. SASU covers main 4 areas. There is the fifth one I will talk about, that's included in this slide, which is the standards and the conformity assessment and the quality, the metrology and laboratories. This 4 pillars is form what we call the quality infrastructure. The quality infrastructure in any system in the world, it should be included this 4 pillars, and there is a 5th, which is the accreditation. The accreditation is very important pillar form the quality infrastructure. Now, I'll talk about our national committee. SAS always aims through the national committee to develop the process of preparation of standards by giving equal chance. This is the main purposes of the technical committee. Give the equal chances for the main for the main sectors in the country, or for the in our society, which is the public sector and the academic sector and the private sector. This is our stakeholder. This is our stakeholder. We stick with him to give equal chance for each of them to have their point of view and opinion regarding any standard that's being processed through our national committee. This is all the total of standards just issuing by our national committee. Is now 65, distributed in different fields: the protective clothing, the food protection, and the personal equipment for the protective against fall. Now we are talking about how can this national committee get involved with the international work. We talk now about the ISO TC 94. This is which is related to the personal and protective clothing equipment. The scope of ISO TC 94 is the standardization of quality and performance of clothing and personal equipment designed to safeguard person against hazards. And this graph show you, this picture show you the all different type, start from the protective clothing, the foot protection, the eye, the legs, all of the different type of protection. The membership of ISO TC, this is a very old committee. It's back to 1959, and the number of countries that are participating in this committee is around 31. So there are one of them. And this is the map of the countries participate. Of course, the yellow color here is representative the participating country, which the B member, and I'm sorry, the blue one. The yellow is related to the observing country. And SASO now is a B member in this country, in this committee. This is all the standards issuing by this committee. One is 139. We come to our conclusion now. Our outlooks, what we are looking for. Now we are B member. We are mirroring all what comes from the parent ISO TC 91. And what we are looking for, the twinning. The twinning is a new concept of the merging or the international work. How can you work side by side, shoulder by shoulder with the main or the parent international committee? This is my presentation. I hope it's a quick one. I hope I get clear what we have done here in SASO and what our outlooks about our international work. Thank you for listening. And now we just invite Engineer Balir to have his presentation.
Assalamu alaikum, sabah al-khair. My name is Bali Gaba Hussein, and I'm the country leader for Doubont, Saudi Arabia. I'm pleased, on behalf of myself and my colleagues, Dr. Jean-Claude Ward, Mr. Miguel Gonzalez, and my friend Khalid Sadhan. We are extremely pleased to be here among you, and also having this opportunity to be hosted and supported by SASU to have such a gathering happening. And I think we are committed like before to support this relationship and take it to the next level, and also trying our best to help SASU in its mission in creating value for the local consumer in Saudi Arabia. So again, thank you very much for being here, and it's an opportunity for us really to do something and present something in front of you, and bear the proposal of my friend Mr. Saad that he wanted me to present something about our company, because our company sometimes seems to be, I would say, difficult to understand, and needs, aside from presenting our business cards, introducing what we do and how we create value to the society, at the same time create value to our shareholders. So we are engaged in all levels, and we try really to harness science to make a difference in everyday's life. So, looking at the profile of the organization, Doubont only could survive in this world for the last 2 centuries simply because of having strong foundations. And those foundations are considered the core values. And those core values have been, I would say, the secret recipe of the success of Doubont. Not only the scientists or the unique capabilities of putting engineering to work, but the core values. Because if you want to achieve success, you need to have strong foundation that will help you really navigating through the challenges that humanity will always face. And those core values are related to safety, people respect, and environmental stewardship, and as well as the behavior, ethics. These are the things that will always create a healthy environment for workers to perform and outperform, and create value to help the societies that they operate in. Our purpose as a company is to bring science and engineering together to manufacture goods at the end, to provide solutions that will create value. Yes, it's a business, no doubt about it, but at the same time, we try as much as we can to address specific needs that will always really create a mutual interest between our business interest and at the same time the needs of people, the needs of societies, the needs of organizations or even governments. So it's a matter of creating value and how we can create value and contribute to the global society. Simply, we deploy the engineering capabilities we have and the science together as a formula to create an output that will really help sustaining the development of the humankind. So, going back in history, as you can see, as I mentioned earlier, that we have 2 centuries of emergence and development. And the company started making explosives, not necessarily the best field to start a business with, but really it's a chemistry at the end of the day. But we said we had enough of the explosives, so in the 1900s we started focusing and zooming more on chemicals, and those chemicals basically pioneered lots of domains and areas related to plastics, automotives, and those materials that we have manufactured in the 2nd century or the beginning of the 2nd century of our history have really enabled lots of industries to move forward. So we always find ourselves enabling other industries to go forward and provide, I would say, how can I describe this, as enabling solutions that will work hand in hand with other industries like the automotives, the construction, engineering, and so on and so forth. And recently, I would say where we are at the moment, and as we are sailing in the 3rd century of the history of the company, we are into the integrated sciences, because sciences cannot be kept in silos. Sciences have to be merged and overlap and we can identify these overlaps and have them utilized in order to continue our mission of creating value. So what are the segments that we are currently operating on and trying to provide solutions? I would say the core markets can vary from agriculture to nutrition and health, coming down to industrial biosciences. And these industrial biosciences really have, I would say, multiple dimension type of exposure to different industries, varying from refining to households and others as well. So these industrial biosciences have unique capabilities to serve lots of industries. It's a great industrial platform. And also we have the electronics and communications, which include also the photovoltaics for the renewables. It's part of that. And broadly saying that if you look into any sheet, PV sheet or photovoltaic sheet, we will find our chemistry serve at least 8 to 9 components out of 11 components that will shape up, I would say, a photovoltaic sheet. Yeah? We also have a role to play in the performance materials, normally focusing on automotives. You will find whether it's under the hood or on the dashboard in the car, we have lots of our components really exist in your car. So most of us or all of us came to this place while driving a car. And I think our chemistry have existed in most of those brands that we are well known globally. Last not least is the safety and protection, which mainly focuses on harnessing material science to provide protective barriers or solutions in different industrial segments. So open innovation as a concept is growing and emerging. And we are not the only company that really work in that area. Open innovation means that you bring all the stakeholders around the table to introduce your capabilities and how you can find a way where they can harness and utilize your expertise or knowledge. And to make it happen, Dubont, like so many other multinationals, have adopted the concept of putting innovation centers all over the world. And most of them, if I would say 75% of those innovation centers exist in emerging markets that we describe, not necessarily in the West or the more industrialized world. But as you can see from the geography where all these facilities have been set up, they mainly exist in countries where the growth will always have a higher potential than the rest of the world. So I think this is the end of what I want to introduce today. And it's a kind of good opportunities for us at least to explain what we do and who we are, because sometimes we feel that people ask us all the time what Dubont is about, what you guys are doing mainly. So hopefully this short introduction would help you guys or would help ourselves getting introduced. And please feel free to ask questions, and hopefully I have utilized the 10 minutes that I was given in a very effective way. And again, thank you very much for being here. Thank you.
We will have now a break for 15 minutes. Then we will come back to our main presenter, Dr. Jean-Claude. Thank you. Yeah.
نايف.
Hello, hello. This is like this. Yes. Okay. Okay. Now works. Yes. Okay. Perfect. Okay.
Now
Thank
silent.
you. Silent. Okay. And then when I start, I push. Okay. Thank you.
موجود عليه شيء بالكنترول. موجود في الكنترول.
Okay. Perfect. Thank you. Yes, yes. I have to push.
Assalamu alaikum. We just welcomed Dr. Jean-Claude now to present his lecture.
Okay. Thank you. Good morning, everybody. So my name is Jean-Claude Duhard. I'm working for DuPont company, based in Geneva, in Switzerland. Over there we have a lab, an important lab where we're doing R&D development. I'm part of the technical team from this lab. But I have also responsibilities at the IC level. And this morning we wanted to give you a presentation. I will introduce a presentation which is about protection of workers, as we are mainly looking at the industrial world, as you will see, but it's towards a specific danger, specific risk, which is the electrical arc flash risk. So the purpose of the discussion this morning, we wanted to introduce that risk. So I will be going through some elements that will help you to understand what are the challenges, what are the risks, and what are the standards that are either in place or under development, because as you will understand, this is a very young discipline, if I may call it. And for that, I will use a presentation which helps to go through that we call the 4P methodology. The aim of this is really to introduce to this area. I understand that there are electrical specialists in the room, so they're probably aware. But maybe for the rest of the persons you are from SASO, that will be a new area, new field. So please don't hesitate to note questions. We want to have the opportunity to discuss and generate some comments and questions. So the purpose of this is really to help you also to get an understanding of that specific area, as I said, which is still pretty young if you consider the development of standards in the world. And again, thank you for the opportunity given. This is not often that I have the opportunity to talk in front of such a large number of specialists. So to introduce and to understand the dangers and the hazards linked to electricity related to arc flash, we have a simple way of positioning that, which is what we call the 4P methodology, which is a process that helps also the industries to acquaint for this risk, because a lot of industries are not yet ready. You will see, I will present the evolution around the world, how this discipline has been evolving in the last 2 to 3 decades. So this methodology that I will go through step by step, we call it the predict, prevent, protect, and publish, is not a methodology of DuPont. You find this in many books or papers that are written. So it's a general methodology to help also companies to assess risk. And I will use this for the electrical risk, but it can be used for any other type of risk, explosion risk, it can be a chemical risk. So this is a general approach. So nothing really that we have invented here in DuPont. This is something that we have taken from the community. So just to give, my colleague Balig already gave you an idea of the culture of DuPont. So I will not spend too much time. But again, it's important to understand that for us the safety is really part of our DNA. So we've been looking for more than 200 years, you know, into the aspects of safety. And you will see how this has influenced us coming into the electrical risk and the risk linked to electricity. Now, electricity, industrial electricity, has been invented a little bit more than 100 years. Again, the electricity was known from more than 2,000 years, but the industrial electricity, generation of electricity, was really at the end of the 19th century, when the network started to be built, when the generation, the transmission, and the usage of electricity became more common. And since those times, the fear of people is mainly the contact. So and you know that, at your house, you make sure you protect yourself, you protect your child, not to touch any electrical devices, because that could be a risk for your life. And this risk is the one that most of the engineers, electrical engineers, have been facing. But there is another risk that has been generated over time, that has been discovered. And that risk, this is the one that we will get into a little bit more detail today. That's the risk of an electrical arc. The industry is generally facing this challenge. Why the industry? Because this is where you will find the power being installed. Generally, in a building like this one, none of us generally will get in contact with electricity. We will use the electricity, but generally we are protected. The difficulties will come when we have a room somewhere in this building where we are powering all the building, where we have electrical devices, cables, transformers, switch gates, and when we will have to do maintenance on those. And that's where the risk of electrical arc flash will come, and this is what we are generally talking about. So, making an assessment of this electrical hazard, it will be a key element to understand the level of protection that you will need to have for those people that will be in contact with that risk, or that could be in the vicinity of that risk. So that's one of the challenges that the industry over the last several decades has been facing. Obviously, it's been important to make sure that you comply also with some of the regional directives. Here I put the European directives, but there are directives in North America, there are directives in this region. Each countries or each regions generally will put some directives that you will have to comply to make sure that you protect the people that will have to interact with those electrical systems. And then it will be important also, very often you have directives or you have regulations that force the employers, force the companies that are using this energy to protect their employees, not just protecting from a point of view of protective apparel, we will discuss that, but also develop or change their systems to make those systems less hazardous. And again, I will show you some examples how the methodology is working. And obviously, as we call it, the last line of defense is the protection of the body, and that's where the PPE and the adapted protective apparel will have to be taken into consideration. You will see, I will go through some of the standards that are regulating these choices or the development of those PPEs. But before that, a little bit of history, and we are kind of proud in DuPont of that, is that the first engineer that really thought about the second, as he called it, it was a paper that he wrote in 1981. That gentleman is named Ralph Lee. This is today still considered as the first engineer that really looked into the risk of coming from electricity from an arc flash. So not from the contact. You are now, in this case, you are exposed to an arc flash and you will be submitted to heat. A very important amount of heat, but there will be no contact. So we are not talking about the shock protection, which is something that people have been made and protecting themselves for many, many decades. We are talking about another risk. And this engineer, which worked in DuPont, had his career from 1942 to 1976. He retired from DuPont in 1976, but still continued as investing his time in electrical. He was an electrical engineer. His job was to develop the electrical networks in our plants, either the new plants or the ones that were built to maintain. And he came with a paper that was written in 1981, so a few years after he left DuPont, that was called the Other Electrical Hazard. The Other Electrical Hazard. Why? Because everybody, as I said, when you think about electrical hazard, you think about contacting, you think about conduction and being electrocuted. Well, what he talked about was about the electrical arc blast burns. Obviously the burns, because when you are exposed to a high amount of heat, you're going to suffer burns. So in this case, we are not talking about any contact, but you are confronted to an electrical arc flash, and this arc flash will have an impact on your body if you are not protected. And so that was really the beginning in 1981 when people started to think about this hazard. Our involvement obviously has been important over the years because in DuPont, as we said, we have DuPont Engineering, that's the group that manages our electrical systems, so roughly was part of that. We have also research and development capabilities that we've been putting efforts to understand that risk and to reduce the effect of that risk. We have also another group, which is the one where my colleagues here and myself are belonging to, which is a group which has developed, in fact, this year we are looking at our 50 years of existence, has developed a fiber at the time called the Nomex fiber. And this fiber is basically a nylon fiber that has been improved to be heat resistant. And this fiber is used today in many applications to protect from the heat, to protect from the fire. Like, for example, the firefighters will be using this fiber for the protective garments. But it has also capabilities to protect from the heat. So all that experience, but also, as my colleague was seeing, we also had looked to external experts, external consultants. So all that expertise has resulted in us trying to advance the knowledge and also the solutions to face this hazard. So the presentation of today will give you a little bit of that path and will show you through the times also what are the standards that were developed, some that we are participating in. Personally, I am a member of the Technical Committee 78 inside of IC. So I'm a member of IC, and I'm participating in some of the standards that I will describe in my presentation to develop, improve, or sometimes generate some new, because as you will see, this is still a pretty young area, so a lot of standards still have to be developed. So let me go into this way of introducing the situation. So this 4P methodology. So we call it predict, prevent, protect, and publish. The first step that the industries will be confronted when facing this danger is to calculate and validate the level of the hazard. Once they start the process, so they will start the prediction, trying to predict the severity of the hazard. You will see how they do that. Then they will enter into a second step, which is the prevent. So they will try to mitigate the hazard, to reduce the level of risk for the exposure that could happen to the people. So that's and as long as you analyze your electrical system and you can reduce that risk, you can mitigate the hazard, you will do rotations in order, iterations, excuse me, not rotation, iteration, in order to reduce that. Once you consider that step is finished, that you have reached an acceptable level or a level that can be manageable, then you will enter into the next phase, which is now protecting, because there's still generally what we call a residual risk. And now you will have to protect the people, you will have to protect the workers from that residual risk. Excuse me. And generally, as you will apply the protection measures, those protection measures will consider the solutions for the PPE, the protective, personal protective equipment, but they will consider also some other elements like the training of the people, as you will see. The last element is, we believe it's critical because that's the element that will also foster your organization to move into facing those kind of hazards, is the one that we call publish, but which is in fact really looking at documenting and training the people, making them understand that the information is available, that they understand this information so that they understand the risk that they may be facing when they are operating, when they are doing maintenance in the electrical systems. So we'll go step by step in each of them. I will show you what is happening and also the link to some of the standards that have been developed. So in the first step, as I said, really we are looking here at assessing the level of the hazard, the severity of the hazard, how much is that important. So just to give you an idea, and you will see these numbers very often in my presentation, the heat that we are looking at exposing the part of the body is generally about energy that really carries that heat. To give you an idea, the level today that is considered to be a threshold for a danger for the human body is 1.2 calories per square centimeter. This amount of energy applied to the skin for 1 second, so just to give you an idea, this is like if you were putting a lighter under your hand at about 10 centimeters for 1 second. You will get on your skin basically what we would call the second-degree burn. So that will be the threshold of a second-degree burn. So this number is quite important because it has been the model for many equipments, many devices, to understand what could be the effect of the body of given amount of energy. So the point is that you need to calculate for any electrical devices, any electrical equipments that do have enough power, you will need to understand what is the amount of energy that can be emitted in the case of an electrical arc flash. So you will have to develop a simulation of your system, and that will allow you, as you drive this simulation and you use some specific softwares that have been developed, will allow you to calculate what is called the incident energy. And this is basically an element which is defining the amount of energy that a given system, a given installation, could generate in case there was an electrical arc being generated. This amount of energy is expressed in kilojoules per square meter. That's the ISO, the international standard unit. But most often, people are talking about the calories per square centimeter. At the same time that you evaluate the amount of energy that can come from an electrical equipment, you will have a second element that will have to be calculated, is what is called the arc flash boundary. What is the arc flash boundary for a given equipment is the distance in which, once you pass that boundary, you will need to be protected. It's a boundary that has to be defined in order for the people, for the workers to understand that once they cross that, they have to be safe from a protection point of view. They have to have the correct PPE that protects the body, protects the hands, protects the face, and really gives them an opportunity to do the job that they have to complete in terms of maintenance or in terms of installation of equipment under certain conditions, under live conditions. I forgot to mention that the TC78 within the IC is the technical committee that looks to the live operation. Operating in live, that means operating with systems that are connected. So, unlike, as it was mentioned this morning, in the ISO TC94, we are looking at many segments of the protective equipments, but for the electrical risk, the protective equipment is defined inside of the IC. So this is where you will find most of the standards that are related to protective equipment. So, in order to do those calculations, a set of curves were developed by this colleague that I was mentioning, Mr. Ralph Lim, and they have been put in a standard. And today, this is still the only standard in the world that has inside the calculation, the curves that allow from an electrical system to do the calculation of the incident energy and the calculation of the arc flash boundary. This standard is the IEEE 1584. The last edition was 2002, and this was the edition, as you can see, recent edition. So we are not talking about standards that were developed many decades ago. So those are still pretty recent standards. There is a new edition which is now under revision by the IEEE committee. We think that the new version will come probably next year, maybe in 2 years. There's a lot of questioning about this new version because it tries to integrate higher voltage, going up to 15 kV systems, and also looking at DC. It's important to understand that today most of the risk is coming from AC systems, alternative current, but as you may know, there is a lot of development of DC applications. I will give you two very basic. One is the solar, the photovoltaic systems. Today they are in direct current, in DC, and you have also now the development of electrical vehicles. So today, in a HEV, hybrid electrical car, you have a lot of power, which makes that either the people that are building those cars or the people that are doing maintenance, now we have to look at protecting those people because there is opportunity or risk for an electrical arc flash. So that's why the DC now, a lot of questions are coming from the industry for protecting not only from the AC, but also from the DC, direct current. But at this stage, this guide, this IEEE 1584, still remains the only standard in the world that helps to do the calculation of the arc flash boundary and the calculation of the incident energy. This standard, the formulas of this standard have been incorporated, as I said, in many different softwares, but again, the origin is still this one. This leads also to the understanding that today, the most advanced country in the world about electrical arc flash is USA. They have assessed this risk. Our colleague was one of the first ones to assess the risk in the beginning of the 80s, and since then they've been progressing. As you will see, I will cover the IC standards that relate to protective apparel, but in terms of assessing the risk, IC has not developed any similar tools, nor any other regions on the world. So this standard, the IEEE 1584, still remains the base, and that's why in the group which is working on this, which is IEEE group, there is a lot of experts from the rest of the world. One of the, I would say, advantages of the IEEE committees is that they allow for experts from other regions to participate, and that's in that case, it's a benefit because everybody is taking advantage of that. So, just to give you a little bit of understanding of the danger that is being faced, this is a very simplistic simulation of an electrical network. So you have generally the high voltage and high current which is supplied, you know, from the utility. For example, here in Saudi Arabia will be Saudi electricity. They will be the ones providing power to buildings like this one. And then generally you will find a first stage which is generally the transformer. Electrical transformer will allow to reduce the voltage, so it can be used in the plugs to power the computers, to power the kitchens, to power any electrical devices that we may have in factories or in houses. And then you will have a series of systems with cables, switching devices that we will need to analyze at each level what is the level of energy. And what is important to understand is that the level of energy that can be emitted, there's two key parameters. The first one is the amount of the current, and the second one is the duration of the current. Those are the two elements that will help to determine the amount of energy emitted. How much current is going through the system during the arc flash event, and for how long? So those are the two key parameters. Obviously, one element which is important to consider is the distance of the worker to the event. As we said before, you will see the programs are allowing you to calculate this minimum distance. But just from an understanding point of view, as you get closer to an arc flash, the elements that are determining the energy is obviously the type of equipment, but the elements that are determining how much energy the worker will be exposed to is the working distance. To simplify, if you divide the distance by 2, you will have generally the incident energy will be multiplied by 4. So it's a relation to the square. If you divide by 4, you will multiply by 16. It's easy to understand. The closer you get, and the more your body is representing a level will receive energy, because you are representing a bigger surface as you get close to the incident. So but that's a critical point, because as you understand, the maintenance, you don't do generally the maintenance meters away. The workers will have to get closer to the equipment, and then they will expose the body to more energy. So that's one of the elements which is important to understand. The second one, we said, and the definition comes from the standard IEEE 1584, the arc flash boundary, this boundary within which a person could receive a second-degree burn from an arc flash incident. So once he crosses the boundary, the people will have to be protected, because in case of an event, they could be exposed and they would receive a second-degree burn. Very often, we have the question about workers have to be protected, but what about the supervisors? Well, it's important to protect the supervisors, even though they don't intervene. In case of an incident, they may cross that limit. And if they cross the limit, then they enter into the danger zone, if I may call it that way. In that case, they have also to be protected, because if not, they could be injured, and they could injure their people also. So it's important to understand that as you get closer to the danger, you expose yourself, you expose your body, so you need to be protected. So this limit, for example, in our plants, in DuPont, around an electrical device, you will have on the ground a blue limit. In our case, we have selected the color, the blue limit, so that our people, our workers, they know that if they cross that blue limit, then they will have to have the proper PPE. So it's a visual, but it's important. That's more part of the last phase that I will describe later on, the publish, but it's important for the people to realize that, you know. The danger with electricity is not like fire. Fire, you see a fire, so you know there is a danger. Electricity, you don't see it, you know. So, and until an event happens, you don't realize that there could be a danger. So that's one of the difficulties with electricity. So you need to find ways to make you people aware about the danger. So, just an idea, and again, I will not dive into the details, but this is a real network. I mean, it's a very simplistic network because it's a single network. So where you have the power grid, you have again the transformer that generally reduces the voltages, then you have the cables. So as you do the analysis of your system, you will have to enter all the details. And this is the elements that will allow you, for example, in this case, we have done an evaluation in this switchboard at the end. So we consider the working distance to be 300 millimeters. 300 millimeters is the length of the arm. So that's generally the distance that the workers are from the incident. Now, that means also that the hands will be closer. In case of an incident, the hands will be probably suffering more because they will go to a higher level. But again, in the protection strategy here, what we are trying to protect is the body and the face. So the consideration in all the simulations, all the work that has been done, 300 millimeters is considered to be the distance of the worker that should be used to evaluate and to assess the risk. In this case, in this case, the incident energy that was calculated in case of an incident at 300 millimeters was 42.57 calories per square centimeter. Now, if you remember, I was telling you before that 1.2 is the level for a second-degree burn. So you can understand that more than 42 calories will have potentially even a death impact on the person, you know, because you are now at very high levels of energy. To give you an idea, we are doing in our laboratory in Switzerland, we have one of the 3 labs that are available around the world to do arc flash testing. There's only 3 labs. There's a 4th one which is under development in Brazil, but not yet accredited. When we generate an arc, we generate a hot plasma that generates temperatures between 15 and 20,000 degrees. So more or less 4 to 5 times the temperature of the sun. So in this small space, you will get a lot of heat. And this heat will evolve, will move as a matter of a plasma, and could impact and will impact the body if you are not protected. So that's why the amounts of energy are generally pretty high. So in this case, in this example, the calculation came to 42, and the arc flash boundary, you see a little bit more than 1.7 meters. So that means that if you are not protected, you cannot get closer than 1.5 meters. So that means that maintenance is obviously difficult, so you will have to cross that line. So if you cross the line, then you need to be protected. But before going and talking about the protection of people, let me just go through the second step, which is the mitigation and reducing of the risk. In that second step, we will now look, and generally this is the case for most of the regions, the companies that do operate with electrical networks in the plants or in the factories will have the responsibility to try to mitigate that risk, that hazard, and reduce the risk. So for that, they will look to a possibility of changing the equipment. They will maybe change the protection settings when they do live work, you know. They will, in that case, as they do that, then they will recalculate the hazards, you know. The risk reduction is not only about equipment, it's also about people. So you need to make sure that you take into consideration the human factors. You need to make sure that you will make the people aware about the hazard. It could be, I mean, it's can't to be very simple sentence, but this is very important. People have to realize about the hazard. And that's the first element of the protection. Because as they get and they realize there's a danger, there's a risk, then they will act in consequence. Obviously, you need to make sure that you provide training and you assess the competence of the people that are doing live maintenance. So that's also part of the, it's an important part of the reducing the risk, making clear responsibilities of those people, defining the clear procedures for the intervention. So it's not anybody that can do live work. You need to define clearly who can do that, what are the responsibilities, and what are the tasks that they can do. And it's important also, something important, it is not only about the people from your company. In DuPont, we are using a lot of contractors. We have the same responsibility with our contractors because they operate in our plants, they operate in our facilities. We have the same responsibility. They have also to follow the same rules than our employees, you know. So that's also important. You need to think about you, company, but you need to think about also the other companies that are collaborating with you. So that's also an important aspect. So for example, just again a calculation example. This is the drawing I was showing you, the circuit I was showing you before with, as you can see, 42.57 calories per square centimeter. We made a new simulation. In this new simulation, we replaced the fuse. Here, as you can see, you have a fuse. A fuse is a system that will help to disconnect and will help to shut down the current and limit, obviously, the hazard. The time of connection, if you remember, the electrical arc flash, two key parameters, the amount of current and the time and the duration of that. So what's going to be important, if you cannot limit the current, is to limit the time, because the shorter and less energy. And in fact, here in this example, we have replaced the fuse. We put what is called ultra-rapid fuse. So by the name, you understand that this fuse will act much faster. And when you do the calculation, now you end up with 7.1 calories. So just replacing, and this is a very simplistic case, it's just as an example to show you, but as replacing the fuse, we have improved our system. We have reduced the risk, so still we are above 1.2, so we will need to protect our people, but now we will need to protect them from a much lower energy. And this is important because, as you will understand in the second part of my presentation, the more energy and the more protection you will need, the more layers generally, and that makes also some protective equipment that are more complicated to use, more heavy, less respiratory. So it's important also to consider the comfort of the people, not just the protection. So that's why reducing the level here is critical. Let me go now in the third step. We are now looking at the residual risk, as we were discussing. So now we're going to need to look at the optimal solutions, you know, and how those solutions are defined. So I will enter now more into some of the standards that have been developed in order to evaluate those solutions. Generally, as you look to the protection of the body, you will be looking at the body, but also the face and the hand. This is, today, what is important to understand. The first stage that, as we said, we are trying to protect from the heat. So today, as you're looking for arc protective clothing, before you evaluate the arc protecting capability of a clothing, you need to validate that the clothing is also fire resistant. Why? Because those fire resistant clothing are generally heat resistant. And for that, the base is to look at the ISO 11612. The 11612 is the base for helping to define the requirements for the flame protective and heat protective garments. So this ISO, which has been superseding in Europe a yen standard, is now the internationally accepted standard with a different level of performance that you will be evaluating on your garment that will allow you to consider and to establish or agree that this garment is heat and flame protective. Once you have that, then you enter into validating whether the garment will be electrical arc protective. And for that, as I said, this is now dealt not inside of ISO, is now dealt inside of IEC, the International Electrical Commission, which looks at obviously all the matters that are related to electricity, which includes the protective apparel. So, as I said, the TC78, the Technical Committee 78, is the committee developing the standards. So the main one is the IC 61482-2. This is the one that provides the requirements. Excuse me. So as I said, it's live working. So this is part of the TC78, which is live working. And this standard will look at the protective clothing against the thermal hazard of an electrical arc. At this stage, it is important to understand one thing. When an event happens, an electrical arc happens, there are many hazards. The one which is today only appearing in standards is the heat. But when you have an electrical arc, what's going to happen? On top of the heat, you will have a pressure. It's an explosion. You will have sound. So that's a threat. So the pressure could have a trauma. The sound could have an impact on your hearing capabilities. You will have bright, intense light. So obviously impact on your eyes. You will have some metallic parts in fusion that will be projected. You will have some metallic parts also, not in fusion, that could be projected and impact the body. So when you have an electrical arc, there's many dangers that are coming. The only one so far which is covered in the standards is the heat. So that's why, again, as I said, this is still a pretty young discipline. Not all the aspects have been yet taken into account. A lot of work for the engineers that are interested in developing standards. We were discussing that during the breaks. Unfortunately, sometimes we're missing engineers. But this is a discipline where still a lot of work has to be done. So, but one aspect, and the main aspect we believe, which is taking into consideration, is the thermal hazard. So this standard looks at the definition of protective equipment only in view of the thermal standard. So just I want to be clear here, because sometimes people are asking about whether it's considering the pressure, is it considering the light? No, not in this standard. It doesn't mean that we know that there are such risks. So for the eyes, you will want the people to have maybe some lenses that are colored and not white. For the ear, you will want your people to wear some protective hearing, but there is no standard defining this. So there is, together with this standard, which is looking at the requirements, there are two standards that were developed within IC, which are relating to the test methods of the protective clothing. I will enter into details on those two standards in a minute. Just also an indication, we are not allowed yet, so that's why I have not changed my presentation, but there will be a new logo for the clothing when it looks to thermal protection of electrical hazard. Right now, the garments have to wear the double triangle, which is the double triangle. It's for all those electrical PPEs that are facing electrical risk. Now, for the PPE that will be facing electrical arc, there is a new logo. We are not yet allowed to use it because it has to go. It was defined in IC and in ISO. Very soon it will be published, and then we will be able to use it. So that's why I don't have it yet in my presentation. But there will be a new logo. It's a logo like this one, like this kind of shape. And inside, it's a little electrical arc with a protection effect. So, as I said, I could not present that today because we had some discussions 2 months ago in the IC committee, and the IC prefers not yet for the people to present that, but very soon it will be available. Just to mention two other standards, as I said, we are still in an area of development. There is two standards that are currently under development. One which is for the A, face and head protection. And there is another standard, also all those are part of the TC78. There's another standard which is looking at the electrical performance of hand protection equipment. So those beyond protection of the body, the other two areas that are critical are the hands and the face and the head. For the face and the head, the work is led by a colleague or a partner, which is a person which is coming from the ISO standard. Because ISO has already a lot of standards developed about helmets, developed about face protection. So what we have done, we have used a lot of the elements that were developed in ISO and just adapted to the IC. This allows me to talk also about an important element, which is the joint work that is important to be conducted when we talk about protective between the different committees. So in this case, the ISO and the IC, there is several liaison members that allow for establishing those links. But it's not only the liaison members, it's also about engineers that are both participating in the IC working groups as well as the ISO. So it's important to have these capabilities. So in IC and in ISO, we saw the interest for this specific area to establish those very strong links. That does not mean that IC does not have also interactions, for example, with IEEE or with ASTM. And there are. But it's obviously much easier to standardize or to develop work between ISO and IC that it could be. IC is an international body, IEEE is a country body. So there is ASTM is also a country body. Even though they sometimes consider to be international bodies, it's not generally the case. So that's why sometimes there is some difficulties. So, but between ISO and between IC, very good connections, particularly at least in this area, which is the one I know. Maybe there are other areas. but in this one, definitely very good interaction. So, as I said, important to understand, just to finish on this, that there is still work ongoing in this area. There are still standards that are under development. Nothing is casted yet. So it's an area under work, if I would call it this way. Okay, so this one, the head and face protection, we were waiting for the ISO to emit a standard which was emitted end of last year. So we hope to complete, I'm part of the working group, we hope to complete this one by this year. The colleague which is leading this hopes that we will go through the submitting of the document. Again, in IC, a little bit like ISO, you have several steps. You have two drafts, CD, CDV, then you are going to the FDs. I think it's like the ISO. So here we hope to enter before the end of the year in the first, which means that you still have probably another year and a half or 2 years before really getting to the large stage, which is the voting, the balloting on the FDs. Okay? This one is still, this was a PWI, a pre-work item. So we are not yet, we have a document, a draft document, but it has not yet been circulated. So we are a little bit further away. So here we are probably talking about 2 years, 2.5 years of work. Currently, and I will now go into the next slide, I will talk about the testing methodologies. Excuse me. The 61482-1-1 is currently under revision. In fact, I should be taking the leadership of the working group. One of my colleagues, which is now retiring from DuPont, will step down, and I will take the leadership of that working group. We hope to complete that new version within the next year, year and a half. Also, we are now entering the CDV phase. So, let me spend a little bit of time talking about those standards because they are important. We are also, as DuPont, we have also interactions here in Saudi Arabia with some industrial companies, and they want to understand how those materials are being evaluated. So I wanted to spend a little bit of time. So the IC 61482-2 is setting the requirements, and then you have two test methodologies that allow for the evaluation of the material inside of the IC. The first one, which is the one that this is the test equipment that we have in our facility in close to Geneva. It's, as I said, a facility that allows to generate electrical arc, where you will expose the garments or you will expose the fabrics that are supposed to protect the body. You will expose those fabrics to the electrical arc flash. So it's a facility that we use as DuPont as a testing facility, but that we use also sometimes for some of our partners or some of our customers as they want to evaluate new solutions they may want to come. As I said, only 3 facilities today in the world, with a 4th one under development in Brazil. So not many facilities available. So in this case, what we're doing is we determine the what we call the incident energy that will impact the garment. This is the test which is called the open arc test. So as you can see on the picture, once you generate the arc in the middle of the equipment, the arc will basically blow out in all directions. Top, bottom, left, right, all directions. So the arc is not constrained. It's open arc. This is the model that has been used now since 30 years, starting in North America, to define and to investigate the dangers of electrical arcs. It's a system which is set up just with 2 electrodes, so it's a single phase, 2 electrodes in between which we will generate an electrical arc. The current is set at 8,000 amps, and what we vary is the duration. As we vary the duration, we will vary the energy. This standard allows for defining two characteristics of the fabrics. The first one, which is called the ATPV, the Arc Thermal Performance Value. To simplify, this is when you have heat coming to a fabric, it's more or less the amount of energy that will be blocked by the fabric that will not go to the skin. So it gives an idea how many energy your fabric, your garment will block. The second one is the break open threshold energy. In this case, sometimes, depending on the structure, depending on the capabilities of the fabric, some fabrics will open. As the heat comes, they will be consumed, they will open, and then the energy will go through. So some fabrics will react different. Some may not break, but they will allow the energy to go through. Some others will break. So two characteristics to allow to understand the behavior of those fabrics. Now, the other methodology, it's a little bit more simplistic in the sense that it's more like a pass and fail test. In this case, is what we call a constraint test. So the arc will happen in a box that you see here. And you are defining two scenarios. One scenario with 4,000 amps and a second scenario with 7,000 amps. And then you verify whether or not you're passing the test, you're passing the criteria. So, and there you will get what we call a class 1 or class 2, where here you will get a numerical value, here you will get only a classification. Now the difference, and the important difference, is that in the case of this methodology of open arc test, the value will be defined in calories per square centimeter, which will allow you to link directly this value to the hazard calculation that we did previously, if you remember. Previously, we have analyzed an electrical system. We have come up with an energy level that could come up in case of an arc. That energy level was, if you remember in the example, it was 7.1 calories. Well, then you know that you need a protective equipment which is at least 7.1. And that, the ATPV or the EBT will give you that relation. So that methodology has the advantage to link directly the results of the characterization of the fabric to the hazard assessment. The second one, not yet. There are works undergoing to improve the methodology from that aspect, but so far, and that's why this methodology is less used. It's only used in few countries in Europe. It's not been spread really around the world like the other methodology because of the reasons that I was mentioning. Here you can link the hazard. So an industry that does an evaluation of his assets, know the energy, then with that they can go directly and look for the proper equipment that will protect the workers. And I will enter that into more details now. So, as we look to the protection of the body, it's important, as I said before, arc rating, that's the A, has to be also FR. So, a fire-resistant garment is not automatically arc rated. But an arc-rated garment is automatically fire-resistant. So, these notions are important to consider because they go together when you're looking to arc protection. So, obviously, different types of garments are available. I will not go through in details, but polo shirts, sweatshirts, gloves. So all those elements that will protect the body, will protect the head, will protect the hands. Depending on the level of energy, you will have a more complex system or more simple basic system. Obviously, a critical element is the comfort sometimes. This is just some examples I will go through quickly, but gives you an idea. What is important to understand also is that when you evaluate the fabrics, when you evaluate the garments, you will evaluate systems that are single layer. For example, this is the case here. We have single layer PPE, 8 calories for the polo, 9 calories for the trouser. But you have also systems, as you need more protection, you can develop systems that are double layer. So in this case, you see the double layer is 43 calories, while the single layer was only 8. One important element to understand, this is a development that one of our partners did. So they developed a special fabric using Nomex, but also using some Kevlar. Kevlar is the twin brother, if I may call it this way, from the Nomex. Developing a 220 GSM material. They were looking to a lightweight and to a protection that was in the range of above 8 calories. And as you can see, they have reached that. Now, what is interesting to notice is that if you take 2 layers of this, it is here, the example here, you see that you don't sum the values. You get much higher value than the sum of the two. Why is that? Well, you need to understand that when you evaluate a system with multi-layers, it's like in your clothing. When you put a jacket on top of the shirt, you have some air in between. This air is protection to your body in case you have heat coming. So as you test 2 layers, you will have also a benefit from the air which is trapped in between those 2 layers. So that's why when you evaluate these 2 layers, when you evaluate these 2 layers of the same material, you will get to a value which can be considerably much higher, which is important because that will help to develop some solutions that provide higher protection levels. Again, all those testing are done according to the standards that I just covered a few minutes ago. Important to understand that as people have to select options, it's important to understand that in a plant, in an industrial plant, you don't have only one requirement. You may have several requirements. So you may have levels of PPE that are covering up to 6 calories, some that are covering up to 40 calories. So then people will have a choice to use different combinations, and it could be combinations associating several layers. So it can be a garment that has 2 layers, but it can be also one garment on top of another garment. So this is an important element. Again, the protection of people, this is one of the critical elements, in trying to help understand how you will protect the people. It's the combination of layers. So in this case, single layers. In this case, double layers. Okay, as we come to the end of my presentation, just to make sure that, because this is also sometimes as people are not really deep involved in ARC, they may consider that every solution, every garment can be protecting. No, it's not the case. You have some materials like cotton, viscose, or wool that will ignite in the case of being submitted to an arc flash. So it's important to make sure that those materials are not used. The same, some synthetic materials like polyester or nylon, not only they may ignite, but they may also melt. So again, those are also important not to be used. So these are considerations which are important. That's one of the advantages of the Nomex, is that it allows, even though it's a synthetic product, because of the resistance of the molecules, it allows to protect from the fire and from the heat, but also from other attacks, like, for example, chemical attacks. As I said, and to close on the PPE, besides the body protection, you need to think about the face, you need to think about the hands. So there are also a lot of other PPEs. As they have to have protection in ARC, even though they were defined under ISO, as I was showing and telling about the example before of the head protection, they have to be adapted because they will have to be tested in front of ARC. So because of that, a lot of materials have to be evaluated and a lot of standards have to be developed. I'll finish with the last step, which is the what we call the publish. As I said, this step is critical because that step is the step critical for allowing the people to get the training, to get the information. important to label and also important to document all the elements. So this is the step which is important because that's the one where you will, in your organization, you will make them understand about the need to protect themselves. It's important that the people understand the dangers, understand the hazards, so that then they can understand why is the reason why it is important to protect themselves. And with that, wanted to thank you for your attention. And now I think we have some time allowed for questions or comments, and we appreciate very much your input. Thank you again for your attention.
We would like to thank Dr. Jan for this such a great presentation. He's provided us with many valuable information and shared with us some of his large experience regarding this topic. And now it's question time. If there is anyone who want to ask.
Dr. Abdulhamid, I'm a consultant in the electrical department here. I don't know about the IEEE equation. Is it take care about the environmental conditions? I mean, dust, very high temperature or something like that, when they take care about the calculations?
Yes, the calculation, the IEEE document and the equations that have been developed there, some been developed by Ralph Lee, still in use, are setting a typical boundaries, in the conditions. I was telling at the beginning that one of the difficulties now to develop the new version of the IEEE is that they have been looking at those conditions, taking into account the temperatures, taking into account the ambient temperatures. So they made it more complex. So I know Jim Phillips, which is the working group leader of that IEEE committee. He hopes that he has resolved most of the comments that were made. But the fact that they made this new document more complex, trying to answer some of the points that you were underlining, has made that is now, I think, under work since more than 6 to 7 years. So hopefully the new document will provide some more guidance. But you're right that the initial documents, some of the areas like the temperature were not considered, not highlighted. So it's a hope that the new version, at least from what I understood from Jim Phillips, yes, it will take into consideration some of the elements of the temperature. But the one key question beyond the temperature is the pressure, sound wave. One of my colleagues in DuPont in the US, they made a study a few years back. As I said, in the case of heat, the two parameters from the arc flash are the current and the time, the duration. But in terms of the pressure, because they wanted to integrate the pressure evaluation in the equations, the study they made unfortunately showed that the current is not the parameter. What is the parameter is the level, because they tested at different levels of current, and the duration, the duration is not the parameter, the current is the parameter. So you have to change the level of current, and changing the level of current, you will get a different sound pressure. So what happens is that if you take 8,000 amps and you take half a second, you may generate an incident energy, let's say, of 20 calories. If now you take a current of 4,000 for the same duration, you will generate maybe 10 calories. However, the sound pressure will be different. So there's no correlation. The paper, if you're interested, I could give you the reference. The paper that he developed showed that there was no correlation between the current and the sound. And this is one of the difficulties to try to find those correlations. So in the new document, I think that there will be some indications about the sound, but still the equations will be looking at the energy and at the temperature, still as the main parameter.
I'm Abdulkarim Khaif,
I
acting
would like to
director
know,
of
please.
textile. My question is, what technology is expected in the near future for your subject?
Excuse me, what technology is expected for?
For this subject in the near future.
I didn't understand the end of the question. The technology for the...
Is expected in the near future.
So technology for the clothing or technology for the electrical equipment?
Yeah, for the electric.
In this area. Okay. So there is, in terms of innovation in this area, there are two elements that are critical. One element is coming from the suppliers of electrical equipment, companies like ABB, Siemens, which are doing efforts to reduce, in those equipments that they are manufacturing, to reduce the level of energy that is emitted. So a lot of work today is engaged in reducing the amount of heat when you have an arc flash incident. On the other side, because that level of energy cannot be reduced below 1.2 calories, a lot of innovation is coming from the apparel, from the protection. So the head with the helmets and the face, from the gloves, and from the body protection. For example, in our case, in DuPont, we are involved in the innovation about the fabrics. So we are looking today, some of my colleagues are experts in development of new textiles, new fibers also sometimes, that will provide more protection. Because generally, people, workers are interested to be protected. When they understand that they have to be protected, they are interested, but then they want to have comfort. So innovation today in the textile industry is the management of the comfort. So, for example, the sweat, allowing the sweat to be emitted, but at the same time keeping lower weight, so they can keep the comfort, they don't have a heavy weight. So in the textile industry, this is generally the triggering element. Associated to that, you need to combine the colors, and you need to combine the overall wearability. So today, in the textile industry, linked to this is generally the area of innovation is that. High protection in terms of energy with lower weight of the fabric to allow more comfort, making sure that you have durability, because that's an important question, making sure that the products are still durable. So you need to look at innovation in terms of the shear resistance or mechanical resistance, and still the aspect. So the coloring is also an important element.
Okay, thank you so much.
Yes, these products are made and designed for protection against the electric shock, but are they also made for the protection against the electromagnetic waves coming from the surrounding, from the environmental works?
Okay, it's a good question, very important question. Very often the electricians, the workers are submitted, or they have to manage other hazards. They have to manage sometimes the fire, but sometimes also, like you said, electrical emissions. Now, in this case, it's important to be clear that in those garments, generally you try to eliminate conductive elements. Not totally. For example, in the garments, there is still always a little bit of conductive elements to allow for the electrical discharge to be eliminated. But these garments cannot be used. They are not insulating from the surroundings frequencies. And the problem is that if you incorporate too much conductive, it could be metallic or it could be carbon-loaded fibers, for example, then you will reduce the capability of heat protection, because as the heat is coming, or those elements that are conductive, they will concentrate some heating points. So what you are asking, it's an important challenge, because now more and more we see the need to combine the protection, not just the heat protection from an electrical arc, but then the protection from frequencies, from... So it's an important challenge. back to your question, that's one area that requires some innovation. In DuPont, we've been looking to some options, but for the time being, we don't have, to my knowledge, there's no solution that combines both the heat protection and the radiation protection. Yeah, you have, for example, for electrical companies, they have people that are working under high voltage conditions. So in this case, the garments are metallized, or they have metallic fibers. These are not good for arc protection because metallic components are not good. They will melt. But they are using this when they do inspection on high voltage lines, because then they can plug them to the ground, to the high voltage line. But those are different type of protective equipment. They are also defined by the TC78. So they are also part of the TC78 scope, but they are conductive garments in this case. But it's a good question, important challenge that this industry has to face, having both frequency protection and also the heat protection. I think there was a question in the back. Yeah.
Dr. Jan, we mentioned about the standards 61482 and ISO 11612. Are these standards, they are mandatory standards?
Are these standards?
Mandatory, obligation.
Mandatory?
Mandatory, the standards. The second one. Are the organizations or the factories, when they prepare their, we are talking about the publishment, talking about the work instructions and specification, when they prepare a specification, does they obey these standards exactly? If there is any accident and in case of any death, when he prepare a report, does they investigate? Does they obey these standards or not?
Yes.
For publishing?
Yes. Yeah. To your first question, yes. It's critical, and we have those standards have been developed obviously by international international bodies, because there was some regulations that were asking for that. So
directives or regulations?
No, the regulations are generally regulations either in the countries. For example, I'll give you, in the US, there is a standard which is called the NFPA 70E. It's a standard, but it's a regulation. So all the people that are managing electricity, whatever they are, electrical companies, whatever they are, like us, DuPont Industries, have to follow the NFPA 70 standard, which asks to follow the standards to define, first of all, to do the hazard analysis, following the IEEE 1584, and then protecting the people according, in the case of NFPA, they will come to ASTM standards. In Europe, inside of the European Union, you have regulations, which just now, I think is the 686, but I could confirm to you the number if you're interested, but there's a regulation which is now becoming a directive, which is asking for, which is mandating the industries to protect their people from electrical hazard. And then they said, yes, you have to follow the appropriate standard regulations. So they have to follow the IEC, for example. In terms of risk assessment, have to refer to the IEEE because there is no other standard available around the world. So yes, there are, either at the national level or sometimes at the regional level, like in the case of the European Union, you have regulations that are forcing the companies, forcing the electrical companies, electrical utilities to follow and protect the people. Basically, they ask to protect the people, and then to protect the people, they have to follow several standards. They have to follow against protection, chemical protection, against fire protection, against electrical protection. That's one of the segments. So yes to your first question. And yes, it's in that case, in case of, for example, as you mentioned, in case of incidents, yes, the first elements will be to make sure that the employer has been following the standards that existed in that area. And that, whatever it's in North America or in Europe or in any other countries that have regulations on the protection of workers, you will have that. You will have this, you will have that imposed to you to follow the standards in place. Now, you may say that in some countries there may not be local standards, and then it's the duty to some of the regional or local organizations to develop those standards.
For the personal protective equipment, you were actually mentioning that it's fine. You were actually mentioning that it had been in a controlled environment, but have you looked into sweats, etc.? How does it actually affect the environment, or how does it affect, let's say, like over here, let's say in Saudi Arabia, you would have dust, etc. Would
Yeah.
that actually put into effect the arcing, or does it actually reduce it?
Yeah.
Maybe actually take into that consideration.
Yes. A good question also. It's true that in the way we test, the evaluation of materials, of fabrics, is made when they are new.
Yes.
You characterize those fabrics when they are new. You have a drying and washing cycle that the standard is asking you. In the US, it's 3 cycles. In IC, 5 cycles. But beyond that, you are considering and you are testing a fabric which is new, basically. So to your point, yes, we know that as the operators are working, maybe sweat may be emitted, maybe spills of oil, maybe dust. So how is that impacting? This is not taking into account into the standards. So the standards are only setting the requirements and are made mandatory for the brand new products. However, you can use the methodology and consider doing some variations. So, for example, you could consider that you want to understand your garment with a sweat, saline water, generally we use. We have done some tests in our lab. We use some water with a little bit of salt to represent the sweat. And then we will put the fabrics inside and then do the testing and see what has an impact. And yes, there is an impact because salt is conductive, so it will have an impact on the values. So in that case, this is out of the standard. This is more about now evaluation. So certain companies will come to us or will come to the other labs and will say, I want to test this configuration or this configuration. Can you help us to do the setup? An important element also, you were mentioning over time, the durability. Some garments are treated to be fire resistant or to be arc resistant. I will take the simple example of cotton. Cotton can be treated to get and achieve those levels. However, they are treated. And then over time, as you are washing and washing, these treatments tend to disappear. So over time, you may lose the capabilities, the effect of that. So in the case of Nomex, for example, it's inherent, the fiber is inherent. So you can wash how many times you want and you will not change. But so here again, some people will ask, okay, can you do the arc rating after 20 washes or after 30 washes? And then you may see some differences, and so that can help to. But again, this is not in the standard. For the time being, there is no standard that evaluates the impact of other parameters. The standard is only looking at what have to be the basic properties when the product is new. Yeah.
You mentioned that in order to reduce the incident energy, that we change the timing, the tripping time, let's call it. But don't you think that will affect the reliability of the protection?
Again, all this, you're right. You need to be, in this case, it was a very simple example that we use for presenting, but you're right. When you do the assessment, you need to be looking you need to be looking at all the parameters of your system. So that's why there are some companies, you know, that are doing this kind of evaluations. And then they will be the ones that will be really seeing what is the best way to reduce. As I said, for example, you may replace a switchgear, an old switchgear, by a new one that has a better, more reliability or lower cutting time. And so then you will improve. But obviously, as you integrate this new switchgear, you need to make sure that it will be integrated in your system and it will not impact the functionalities of your system. So yes, you cannot do, as this is a simplistic view that I put in the presentation, but you're right, all those decisions have to be taken in conjunction of the evaluation of your system.
Another thing about the boundary. You mentioned that in Doubonent you put boundary lines around the equipment. Do you start the distance from the arc source, I mean the fingers of, for example, the breakers, or from the equipment body?
No, it's from the breakers, generally. So from the area where you can have the arc, that's where the calculation is made. So it's not from the door. If you have the equipment, the door of the equipment, the body, as you said, and the equipment is maybe 30 centimeters inside, you will start from the equipment, and you will draw and you will calculate. So not from the wall, not from the body, as you said, of the equipment.
Thank you. Thank you.
Well, I'm Abdullah Al Said from Saudi Electricity Company, the manager of Health, Safety, Environment Initiative. First of all, I'd like to welcome you here in Saudi Arabia and your Doubonent team. And thank you for SASU for inviting us to attend this valuable and value point and presenting. I would like to share with you first, before my question, share with you our best practice in Saudi Electricity Company. Actually, the top management, they sign and commit with the policy that every manager, supervisor, employee, and contractor, they should obey with the standard. We have a standard in our occupational health safety and environment system, and they should apply all the requirements. The first step, if you agree with me, is to decide the starting point and where you want to achieve, or where you should be, and how to achieve that, by whom. So these three questions, very important. You will decide your situation around the workplace, and then you have your action plan, either your 4Bs or your plan, do, check, act, whatever methodology you will follow, and you will end by who will do it. And this is maybe where people facing problem. Who will do, who's the suitable person at the suitable place. So if you could share with the audible, what's required to have qualified, certified person to lead that and the team that they will work with. And thank you very much.
Thank you. Thank you very much for your comments. Yes, it's. I mean, as you are facing this electrical danger, obviously, generally the electricians are those people that are generally facing those. So those are generally the people that will start the first step, which is the assessment. So generally, in your teams, you know that as you have to face this, you will need to have people that will help you to do that assessment. So you will need to have electricians. So this is an important part of the team configuration. But after that, what you need to look is to put a process in place. Now, this was an example, the 4Ps, but as you mentioned, there are other processes. And for that, you need really to have a person that will be implementing the process, will take into consideration not only the technical factors, but also the human factors, because we know that these are critical, you know, in the processes of safety. So generally, inside of the safety departments, you know, health and safety departments, you will find people that will carry those type of approach that are considering the technical aspects, but also the people aspect. Then you have some functionalities about the solutions that you have to develop. If it's related to equipment, the electrical engineers generally know how to manage. If it's related to power, to people protection, then you will need people that are aware about the solutions and can consider the different protective equipment solutions. But again, those people will be functionalities that you're adding really to a team leader that will have a good understanding of the technical challenge, so he will need to have a culture around electricity, but he will need also to be able to integrate, these technical requirements with the people requirements. And we know that sometimes changing the mentality in the organizations is sometimes the most difficult piece, And so for that, I think it's important to look for someone that can help into that journey, because it's not like electricity on and off. No, it's not a switch on and then we are ready. No, it will take time. So you will need to have processes that will have to be solid in time. So someone that really knows about the processes and will make this implementation over time. So it's a journey more than just we are in or we are not in. And as you said, also, most of the commitment has to come also from the top management. So we are looking here to realize about the risk for the workers, but it has to come also from the top management. And I think the example that you are describing in SEC is a good example of how the endeavor is taken from the top down. So that's, I think, for me, one also of the critical elements that will provide the power, if I may say, to put this motion, this journey into motion.
One quick comment here to define not only the responsibility, but also to identify who should be accountable for the implementation from the beginning. Otherwise, everybody can claim responsible. Whenever you say it's everyone's responsibility, it's just like saying no one is responsible. So for the management to be successful in implementing anything, they need to identify who's accountable. So differentiating between accountability and responsibility is very clear and important while rolling out such kind of policies in place.
Okay, I think the last question I ask about smart fabrics, which use electricity circles in these garments. There is opposing between smart fabrics and protective clothing?
Another good question. Today in the textile industry, a lot of work is done around smart fabrics, fabrics where you can gather, for example, information. We need to be careful. For example, there is the integration of RFID, so that you can track, for example, a garment. So this is possible. It is possible to integrate RFID, but you need to make sure that when you do the electrical evaluation in front of the arc, that you know where those elements are. Because we know it's important today more and more to track the life of the garments. That's where the intelligent systems are being put in place. But it's also important to understand that those are what we call accessories, and they can have an impact on the arc rating of the garment. So just to give you, again, without entering into details, you have to test the fabric. But after testing the fabric, you need to test the whole garment. Why? Because you are testing the sewing thread, you are testing the closing of the fabric, you are testing, sometimes there are stripes, for reflective stripes, you have logos. So you need also to consider those RFID labels that are inside, and so it's important. So there is possibility to make intelligent garments that are compatible with arc resistance, but it's important to understand where to integrate. You cannot put it just on the surface. You would have to put it maybe on the inside, so it's protected. So those elements have to be taken into consideration, but you can combine intelligent, smart fabrics together with, to a certain degree. Fabrics that are incorporating metallical elements, those you need to be careful because they will have an impact on the arc ratings. Okay. Okay. Well, thank you very much again, and I hope this will have enlightened and opened maybe some opportunities in SASO for future work. As I said, we are looking to experts, so I think that there is no closed doors in IC, so you are welcome to attend some of the working groups. Thank you again for your attention.